Hey guys, welcome back once again to this YouTube channel where we learn machine learning as lazy people and from lazy people like me. So we were learning the important concept of scaling. Why do we need scaling and how do we do scaling? So the first scaler that we used from pre-processing module of Sklearn was the standard scaler that we saw how to implement and how to get the inverse scaling done if we have scaled some data using the Sklearn's pre-processing standard scaler. So as we can see that we have done the scaling using this standard scaler in this way such that the scale of the data becomes between the between 3 and -3. And the standard scaler works in such a way that the mean of the scale, the mean of the data becomes 0, and this standard deviation variance becomes 1. Now there is another type of scaler that's known as MinMax Scaler. So what does MinMax Scaler do? It subtracts the instance of the data. It subtracts from the instance of the data it's the minimum value of that column. Okay, then divides the value with the maximum value minus the minimum value. So this is the formula for getting the min-max scale, of any data value which we have in a data set. Say suppose we have the value 3 converting. So we have the minimum value 1 and the maximum value 5. So what we will do is we will say the scaled value will be as that's 2 minus the minimum value, that is 1, that is equal to 1. And then what do we do? What is the maximum value? Maximum value is, say suppose 5 minus the minimum value, that is 1, that is equal to 4. And then the scaled value is 1 divided by 4. This is the value that we will get for 2 if we have 2 and to be scaled on this min-max scaler. So now we have to implement this min-max scaler using Python, and the pre-processing module of Sklearn gives us this class. So how can we do that? If we have the same data, same things, so we can say get as the min-max scaler from Sklearn dot pre-processing module, get us the min-max scaler. So min-max scaler, and then when we have imported the min-max scaler, we need to create an instance. That is, we need to create a box. Okay, we need to create a box for this min-max scaler. So we will say mm scale for x, because we have to convert x and y separately. Say suppose in this example we will just convert y. Okay, so we will say scale y, that is equal to min-max scaler. So when we have created the class, when we have initiated the class, now the thing we have to do is to fit transform. That is, we have created a box. Now we need to fit our data in it and then transform the data according to the rules of this box. So what we can say is that scaled y is equal to scale y dot fit transform. We will say dot fit transform, and then what we have to give is the y variable, because we are dealing with y only at this time. So we will get the scaled value for y. Now if we will print the scaled value for y, we will see the range for which it prints the value. So if we say scaled y, then we can see that the range is from 0 to 1. Usually what is the range for this MinMax scaler? It's from 0 to 1, because by default we have a range feature in this MinMax scaler. We have an a range parameter where we give it a tuple where we set it and the range for it. So say suppose if I say here, before this before creating the instance of this, I give it this value that's feature range, and set it to say tuple 1, 2. So now the value that will be converted and I will get the value between 1 and 2. So in this way we convert the values, we scale the values using MinMax scaler, and we can specify the range between which we want the data to be scaled on. So this is the way how do we scale the data using MinMax scaler. So there is another thing is that we can get the scale data back. We can get the original data from the scale data. How do we do that? We just use inverse scale function. So we can say y original. So we can say y original is equal to mm scale y dot inverse transform, and then give it the data that was transforming using this scaler. So what was the data that was scaled? Y. Now if we print y original, we will get the original data that was transferred. So this is the way how MinMax scaler is used when we are scaling the data using the MinMax scaler. And the thing is that here is that we can also specify the range between which the data we want the data to be scaled on. Now the thing with MinMax scaler is that if we have negative data in our data set, what it specifies the range for the scale is -1 to 1. So at that time when we have a negative data in our scale in our data set, we have the scale range of MinMax scaler between 1 and -1. So this is the exceptional case whenever we have this data. It's a default, and if we are using the feature range parameter, we can change the range of the scale that we want to specify. Now there is another type of scaler that is known as robust scaler. So if we have scalars in our data set, we are performing scaling using scalars. Certain times we have the outliers in our data set. That are the values, few values that dictate the whole data set. Say suppose if we have a data set of salaries here, so we have salaries from 45,000 to this value. Now say suppose two persons are having a value far beyond this. Let's say suppose 100,000, this much of salary. So this much of salary, if it is included in our data set, it will be called an outlier, because it's far from the rest of the data set. So it's an outlier, it's an exceptional case in this. So in such cases, our standard scaler and other scalars, what they have a problem is that they have a problem with mean and median, because the median and mean tends towards these high values. So at those times we have another scalar that is known as robust scalar. What robust scalar does, it removes those outliers, simply removes those outliers and gives us a scale of data best for in such cases where we have outliers. So how can we implement this robust scaler? In the same way we have implemented the MinMax scaler and standard scaler. So the thing is here we have to import it first. So let's import from sklearn dot preprocessing import what? Robust scaler. Now we need to create the box, we need to initiate it. So what we can say suppose we can say rs is equal to, we will be using this scaler for only y variable, and we will see how to inverse transform the same data. So we will say create the box for robust scaler. Now we have created the box for the robust, using the robust scaler, we have created the rules. Now the thing here remains is to get our data, place it in this box, and fit that data, change that data according to the rules of this box. So we can say, suppose we can say RSY, because we are changing the y data, we will say RSY. Now the thing is same as we were doing with the rest of the scalars. We will say rs dot fit transform, and what we want to fit transform, that is the y variable. Now if we will print rsy, we will see that our data has been changed. So we can see that the data has been changed. This is the way we implement robust scaler. Now here, if we have to transform the transformed scale back to the original scale, we can simply say y original is equal to rs, the scale which we created, dot inverse transform. And what do we want to inverse transform? The transformed data, the scale data, that is rsy. And if we will print the y original data, we will get the same data that was previously present in our data, that is 45,000. And these are the salaries of the employees in our company. So in this way, we implement the standard scaler, the MinMax scaler, and the robust scaler. And in the same way, we inverse transform from all those scalars. Now the reason we do inverse transform is that when we have scaled the data towards some scale using the sum scale, and when we make the predictions, those predictions will be in the same scale that was used to transform that data. So in order to get the original data, we have to inverse transform the same data, the inverse transform the predictions that we got towards the to the original data, to the original scale, so that we can understand the value that is here. Because here we can see that 45,000 is being converted to minus 0.404. So I can't guess what is this the salary, why negative salary. It's not possible. So we need to back convert this value so that we can understand that it actually means 45,000. So this is the reason we inverse transform, because we have to ultimately we have to transform, because back transform the data. If we are transforming the data using some scale, we are just using it in order to increase the efficiency of the machines, in order to make machines work with data fast, so that they can understand this data fast. That is the reason we do this scaling, and that is the reason we do this inverse scaling. That was all in this video. I hope you understand the concept of scaling. Why do we scale the data, and how many types of scalars are there in Sklearn's pre-processing module, and how do we implement those scalars? Because scaling the data becomes a very important factor when we are dealing with deep learning, and when we are dealing with those data sets that have a lot of different scales in our data. So it's very important for us to understand this scaling. So I hope you understand the concepts that I just showed you in this example, in this video. And thank you. Say wallah. And I hope you will be doing well. Thank you so much. Thank you so much for watching this video. I hope you understand.